calculate the enthalpy of formation that can be obtained by the sum of all the reactions goes with the standard enthalpy. Where the carbon monoxide is a gas which is further reacting with an oxygen, okay, it is giving rise to carbon dioxide, which is a gas. We want one more compound, that is carbon dioxide. So I'll take carbon which is reacting with an oxygen and giving rise to carbon dioxide. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. In our last discussion, we have discussed about the measurement of change in internal energy and change in enthalpy by using bomb colorimeter as well as with a colorimeter. And also we have learned about what is thermochemistry and enthalpy change during the reaction, that is a reaction enthalpy we have learned. And also we have learned about the standard enthalpy of reaction and standard enthalpy of formation. Today, we'll move on to the next topic of this unit by understanding the Hess's law of constant heat summation, and also we are going to solve some of the numerical. First, we will see what is a Hess's law and what does it states. If a reaction which is taking place in a several steps, then its standard reaction enthalpy is the sum of standard enthalpy of the intermediate reaction into which the overall reaction may be divided at the same temperature. So what does it tell? Suppose if I am carrying out the standard reactions, to that if I wanted to calculate the enthalpy of formation that can be obtained by the sum of all the reactions goes with the standard enthalpy. So the heat change can also be state like this: the heat change that takes place in the chemical reactions is independent of time taken and the number of intermediate steps which has been involved. We can calculate the enthalpy of those reactions whose enthalpy can be determined is not possible practically. For example, we can take this reaction. So what does it stand? So the Hess's law, which is mainly meant for calculating the enthalpy of formation of the particular reaction. Okay, if you don't know the enthalpy of formation of a particular reaction, by using Hess's law, we can easily calculate. We'll take up on an example so that we will understand how to calculate the enthalpy of formation of the particular reaction. So here we have a reaction where the carbon is a graphite which is in the solid state, which is reacting with an oxygen and give rise to the carbon monoxide. So what is a delta H of the reaction? That is the enthalpy of the reaction we need to calculate. So we know that the carbon combines with an oxygen to give a carbon dioxide. Correct, no? So the carbon combines with an oxygen which is giving rise to carbon dioxide, and we know that only the half oxygen which is combined to form a carbon dioxide, and this is a solid and this is a gas, and again this is a gas. So the enthalpy change for this reaction is around minus 283.0 kilojoules. So look at the board now. I have written a reaction where the carbon which is in a solid state reacting with an atmospheric oxygen and gave rise to the carbon monoxide, and it is a gas. Okay, the change in enthalpy for this reaction is minus 283.0 kilojoules. I'll consider one more reaction where the carbon monoxide is a gas which is further reacting with an oxygen. Okay, it is giving rise to carbon dioxide which is a gas. The change in enthalpy for this reaction is minus 110.0 kilojoules. Okay. Now if you see these two reactions, what is the reaction I want now? I want a required reaction is carbon plus of oxygen giving rise to carbon monoxide. Now, I'll consider this is my first equation and this is as my second equation. I'll sum of the equation 1 and 2. I'll add the equation 1 and 2 so that carbon monoxide will be get cancelled out, and you can see that the off oxygen will be get cancelled out and give rise to the carbon plus of oxygen, okay, giving rise to carbon dioxide. Now, you need to add the enthalpies here. So, it can be minus 283.0 minus 110.0. If you add these two, minus 393.5. So, this is a enthalpy of this reaction. Enthalpy of this formation is minus 393.5 kilojoules. In reaction, we can easily calculate the enthalpy of formation of that particular reaction. Now, we'll solve the sum of the numerical based on the first law of thermodynamics as well as with the Hess's law. So, first I'll take up a numerical, okay. A gas which absorbs 120 joules of heat and expands against the external pressure of 1.10 atoms from the volume of 0.5 to 2.0 liters. What is the change in internal energy? That is 1 liter of an atom, which is equal to 101.3 joules. Calculate the change in internal energy. We know that the change in internal energy is obtained by the formula of Q plus W. And they have given that the heat is, or the gas which absorb the heat around 120. So, they have given the Q value, that is 120 joules. And you can see that it is a reaction where the gases get absorbed, hence it get the positive value. Now, we need to calculate the W, that is the work done. We know that W can be obtained by a formula of minus P external into V final minus V initial. What is the pressure they have given? Minus 1.10. What are the volume change? That is 2.0 to 0.5. 0.5 liters. So, 2 minus 0.5 is 1.5. So, you will get minus 1.65 liters. Okay. But we need to express this work done in terms of 1 liter an atom. So, this is a liter. So, we need to express because 1 liter will be equal to how much? 101.3 joules. Now, I'll multiply this value, that is minus 1.65 into 1 liter volume, that is 101.3 joules. So, you will get 167.145 joules. This is a work done. So, now we know that what is a Q value, and also we have calculated the W, that is a work done. Now, we can easily calculate the change in internal energy, that is delta U is equal to Q plus W. What is the Q now? It is plus 120. What is the W now? It is 167.145. So, if you add these two, you will get, it is minus now, minus into minus. So, it is minus 165. So, 120 minus 167.145, you will get minus 47.135 joules. So, this is a change in the internal energy. This is how, by using a change in internal energy of the system, we can calculate by giving the work done as well as with the heat which is get evolved during that reaction, we can calculate the change in enthalpy. Next, we have Calculate the total work done when 1 mole of a gas expand isothermally and reversibly from an initial value of 20 dm cube to the final value of 40 dm cube at a temperature around 298 Kelvin, and the R is also given. We know that we need to calculate the work done. So, for the work done, we have a formula, that is W is equal to 2.303 nRT log V2 divided by V1, and we know that what is the R, N and the T. So, that is minus 2.303. What is the value of N? It is 1 mole. So, 1 into what is the R they have given, that is the gas constant 8.314 into what is the temperature they have given, it is 298 into log of what is the final volume they have given. Final volume is 40 and the initial value is 20. So, it is 2 ones are 2 twos are. It is a log 2, and we know that log 2 value, it is nothing but a 0.3010. You will see under the log 20 under 0. So, now place the log value into 8.314 into 298 into 0.30. If you multiply this, you will get minus 1717.46 kilojoules. So, this is how the work done of the system can be easily calculated by using this relation. So, please see that how many moles they have given, what is the temperature, what is the gas constant, because gas constant is a constant value, and see that what are the changes in the volume and put it in a formula, and you can easily solve this numerical to get a 2 marks. Next, we have calculate the enthalpy of combustion of the liquid benzene. Given that the enthalpy of formation of benzene, carbon dioxide and water are 48.51 kilojoules, minus 393.5 kilojoules and minus 285.83 kilojoules respectively. So, here they have given the enthalpy of formation of the 3 different compounds, that is with the benzene, carbon dioxide and water molecule. We need to calculate the enthalpy of combustion of the liquid benzene. So, first we need to write the required reaction. What is the reaction we required now? Require the combustion of the benzene, that is a liquid benzene. C6H6, which will be reacted with an oxygen which undergo combustion to give a carbon dioxide and water molecule. Okay. So, now 6 carbon will be there. So, 6, and now 6 and 7 will be there. So, I will put 15 now, 15 oxygen, and here again 3 water molecule. So, it is 15 by 2 oxygen. Now, you can see that there are 15 by 2 oxygen, and you can see that 6 and 3 and also with the 3. Okay. So, like this, we need to write the required equation, and for this we need to calculate the change in enthalpy. Okay. This is the required equation. We need to find out the change in enthalpy of this reaction. So, for that, you need to write the reaction where the benzene which is formed, where the carbon dioxide and water molecule has been formed. Look at the board now. So, now I will take up a formation of benzene. We know that carbon combines with an hydrogen and giving rise to benzene. Okay. How many carbon we want? 6 and 6 hydrogen. So, 3 2s are 6. So, what is the change in enthalpy they have given? That change in enthalpy is 48.51 kilojoules. Now, we want one more compound, that is carbon dioxide. So, I will take carbon which is reacting with an oxygen and giving rise to carbon dioxide, and these are the solid and these are the gases. And you can see that the change in enthalpy of this reaction is minus 393.5 kilojoules. We have one more compound, that is water molecule, where hydrogen reacting with an oxygen giving rise to water molecule. Again, this is a gaseous state Okay. What is required now? What is the change in enthalpy value they have given? Minus 285.83 kilojoules. Now if you see this reaction, what is my required reaction? I want the benzene. Correct, no? So it is there in the equation 1. And also I want the carbon dioxide which is there in the equation 2. Similarly, I want the water molecule which is there in the equation 3. So now I'll take up the equation 1 and I'll reverse it. Okay? Reverse it. Why I will reverse? Because I want the benzene in the reactant side. That is why I am reversing this reaction. Similarly, I'll take up the equation 2 and I'll multiply it with the 6. Why I am multiplying with the 6? Because I want the 6 carbon dioxide as a product. And I'll take up the third reaction and I'll multiply it with the 3 because I want the 3 water molecule in my product side. So now we'll see how to write it once again. Okay. So the first reaction has to be reversed. So C6H6 is giving rise to 6 carbon and 3 hydrogen atom, that is 3 to the 6. And you can see that after reversing, you know, the delta H value, if it is a positive, it will become a negative. If it is a negative, it will become positive. Okay. Next we have equation 2 and it has to be multiplied with the 6. So it is 6 carbon plus 6 by 2 oxygen giving rise to 6 water carbon dioxide. Okay. So the delta H value which is all has to be multiplied with the 6 and it will, so minus 393.5 has to multiplied with the 6 minus 2361 kilojoules. Okay. Now if you see that equation 3, it has to multiply it with the 3 because I want the product in my with the 3 water molecule. So the 3H2 plus 3 by 2 oxygen is giving rise to 3 water molecule and the delta H minus 285.83 has to multiplied with the 3. So if you multiplied, you will get minus 857.49 kilojoules. Okay. Now you see that entire reaction. What is cancelling? You can cancel it. 3H2 is cancelling. 6 carbon is cancelling. Now you rewrite the remaining thing. That is C6H6 plus, you can see that we have 6 by 2, 3 by 2 and 6 plus 3 by 2 oxygen which is there. So again it will give us to the LCM, if you take, it is 15 by 2 oxygen giving rise to 6 carbon dioxide plus 3 water molecule. Now if you add all the enthalpies of the 3 different reactions, you will get the change in enthalpy as minus 3267 kilojoules. Okay, minus 3267 kilojoules is a required change in a enthalpy. What is this? Minus 3267 kilojoules. Okay, this is how, you know, by using the Hess's law, we can easily calculate the change in enthalpy of the given reaction. So, hope you all understood with this example. We'll take up one more example. Calculate the enthalpy of formation of methane from the following data. See, they have already given the reaction. So, in the first reaction, you know, they have given the carbon and oxygen reacting themselves to give a carbon dioxide. Change in enthalpy they have given. Similarly, the hydrogen combines with an oxygen to give a water molecule they have given, and also they have given with the methane molecule. Now, if you see this reaction, what is the required reaction for me? The required reaction is formation of the methane. We know that the required reaction for this is, required reaction I'll write first. The carbon combines with an hydrogen to give a methane. Okay. So, this is a required reaction. For this, I need to calculate the change in the enthalpy. enthalpy of formation. Correct, no? Enthalpy of formation I need to calculate. So if you see all the three reactions, I want methane on my left hand side. I want carbon and hydrogen on my right hand side. So I'll reverse the equation 3. I'll reverse it. Okay. And equation 1 and 2 I'll write as such. So I will write carbon plus oxygen, both are, one is solid, one is gas, giving rise to carbon dioxide. What is the change in enthalpy for this reaction? Minus 393.5. Now I'll take up the second equation, that is hydrogen reacting with an oxygen and giving rise to water molecule. Okay. What is the change in enthalpy for this reaction? Minus 285.87. I'll reverse the equation 3 now. So, I'll write carbon dioxide plus water molecule, that is 2 water molecule, is giving rise to CH4 plus 2O2. And you need to reverse with the delta H value also. It will become plus value because it is in the minus. It is 890 kilojoules. Now, if you sum up all the three equations, you can see that carbon dioxide will be get cancelled. Similarly, oxygen and half oxygen and this oxygen molecules will be get cancelled out. And you can see that water molecules and water molecules will be get cancels. What is the remaining equation you will get? You will get carbon plus 2 hydrogen is giving rise to methane. Is giving rise what? Methane. And if you sum up all the enthalpy, minus 75.16 kilojoules. So this is the enthalpy of formation for the methane molecule. This is how we can easily calculate the enthalpy of formation of the given reaction by using the Hess's law. We have one more numerical. Calculate the enthalpy of combustion of methyl alcohol from the following data. That is the enthalpy of formation of the water, enthalpy of formation of methyl alcohol and carbon dioxide they have given. We need to calculate the enthalpy of combustion of the methyl alcohol. Okay. So first, I'll write the required reaction for this. Okay. Again, we need to go with the required reaction. So what is required here? We need to take a methyl alcohol reacting with an oxygen and giving rise to carbon dioxide and water molecule. Now, you need to balance the equation here and we have a 3 oxygen. If you see the hydrogen here, we have a 4 hydrogen, we have a 2 hydrogen. So, I'll take up with the 3 by 2. So, now the equation is balanced. So, combustion of this reaction, we need to calculate the change in the enthalpy. They have given the change in the enthalpy of the water molecule. First, we need to write the reaction first. So, hydrogen combines with an oxygen, giving rise to water molecule. Okay. This is a gas, and this is a liquid of water molecule. What is the change in enthalpy they have given? Change in the enthalpy is equal to minus 285.83 kilojoules. Next, we have enthalpy of carbon dioxide. So, carbon with an oxygen giving rise to carbon dioxide. This is a half once again, this is a solid and this is a gas again. The change in enthalpy is minus 393.5 kilojoules per mole. Next, we have the enthalpy of formation of the methyl alcohol they have given. So, we need to write the reaction for the change in the enthalpy, that is carbon combined with the oxygen as well as with the hydrogen and results in a formation of methyl alcohol. Now, you have to balance with this reaction. So, you will get a methyl alcohol. Change in the enthalpy for this reaction is minus 238.86 kilojoules. These are the three reactions. First, you need to write it first. Then look at with the required reaction. We want a methyl alcohol in my right hand side, and also we want the oxygen. So we can easily get, and carbon dioxide on my left hand side and along with the water molecule. Now, I'll reverse the equation 3. Okay. Reverse it and I'll rewrite it once again. Okay. That is, a methyl alcohol is giving rise to carbon plus half water plus hydrogen. Delta value we have minus, it will become plus 238.86 kilojoules. And we have one more reaction, that is carbon combines with an oxygen and giving rise to carbon dioxide. And we have one more reaction, that is hydrogen combines with an oxygen and giving rise to water molecule. Change in the enthalpy of this reaction, that is for the hydrogen, it is minus 285.83. Similarly, for the carbon dioxide, it is minus 393.5 kilojoules. Now you sum up the entire reaction. Okay, it is H2. So H2 will be get cancelled out, and you can see that carbon which also get cancelled out, and we have half O2 and half O2. It will also get cancelled out. Half O2 and half O2. I can rewrite it as 3 half O2. So I'll take up the methyl alcohol plus 3/2 oxygen and giving rise to carbon dioxide and the water molecule. So this is how we got a final equation. Now if you sum up all these, the change in enthalpy values, minus 726.3 kilojoules per mole. Okay. This is how the change in enthalpy of the reaction can be easily obtained by sum up with the following reaction. So in our next class, we are going to deal with the spontaneity of the system. Hope you all understood with this session. I'll come back with the next unit. Till then, take care, be safe. Thank you.